All right, so for our quotient rule today, it looks really, really crazy confusing. It is slightly different from the product rule, and that's okay, not a big deal. The shorthand notation for this, let me just see this for 1 second on the other side. All right, so our shorthand notation for this is going to be if I am taking f divided by g prime, it's going to equal g times f prime minus f times g prime, all of which is over g squared. This is times, this is times. So when I go to do these problems, especially early on, I try to write the shortened formula down just to reinforce it and the differences. So some of the differences are that this obviously has a minus sign in the top. And the other thing is we start with the second identified function. Okay, we start with the second function. So what's tricky, I think, about this problem is that it looks a lot overwhelming. I don't really think that it is. I think that the top is going to be f, and the bottom is going to be g. So I'll do that there. And then we just fill into the spots. So for me, you'll hear me say this over and over from this point forward. Structure, structure, structure. I like to do setup first. So when I go to do my problems, I'm going to pull this over so you can see it right next door. I like to simply say, okay, if this is quotient rule, I'm going to set it up to look like this. Quantity times quantity minus quantity times quantity over quantity squared. That is the quotient rule in its absolute skeleton form. All right? It allows me to let go of having to plug in those symbols and focus on, do I just want the term or do I want its derivative? You know, transferring what these variables mean into the structure. All right, so I'm going to pull this up just a smidge so you can see it. So my g function comes from the bottom, so that's going to go first, x plus 5. F prime is the derivative of up top, so 3x squared. Let me give myself a little bit more room here. 3x squared plus 4x plus 0. There's my minus sign. Then my f function is x cubed plus 2x squared minus 1. And my g prime is 1 plus 0. Now at some point, some of you will stop writing the plus zeros. I'm putting them in just as a reminder, if you're not through the previous lesson especially, like that is the derivative of a constant. It is 0. In the bottom, I'm going to put in my g function squared. All right. Now I'm going to do all the algebra to clean it up. That would be an acceptable form if they just said any form. If we want to simplify, so we can simplify it, we're going to FOIL up top. So the plus 0 goes away. We can get rid of those. Over here, we're going to FOIL, and we're going to get 3x to the third plus 4x squared plus 15x squared plus 20x minus x cubed minus 2x squared plus 1. I could FOIL out the bottom. I don't need to because my goal here is to simplify the top as much as possible at the moment. If I simplify the top further, I get 2x cubed plus 17x squared plus 20x plus 1, all divided by x plus 5 squared. Good? Make sense? Not too hard? In Delta Math, on the right-hand side, there's like a little, I think it's like a little mark where you can see an example. Go in and check that. The requirement for that program may be that you FOIL out your denominator. All right, so look at an example problem through them and see what they do when you have to fully simplify, just to make sure you don't waste your one time wrong just on, a simplification error for a preference that the program has. All right, so now, moving down to example 4, we can do the same thing. The more familiar you are with your derivative rules and setting up for structure, the faster these problems start to go. So, for example, I'm looking at this. I already have my formula written up here. You have it in your notes also. If you need to, just kind of block it out, think about it, mark it down. So as soon as I see this situation happening, where this is my F and this is my G, I'm going to use my structure. I'm going to say, oh, I know what that is. That is quotient rule. So quotient rule says set this up. 1, 2, minus 3, 4. All of which is over something squared. Start with the g function, x to the 4th plus 1 times the derivative of x. 2x plus 0, I can get rid of the 0. Minus the f function, x squared minus 1. Over 4x to the 3rd plus 0, I can get rid of that. In the bottom, x to the 4th plus 1 squared. If I simplify this up top, I'm going to get 2x to the 5th. So this is just distributing here and here. Plus 2x minus 4x to the 5th plus 4x to the 3rd. All of which is over x to the 4th plus 1 squared. Negative 2x to the 5th plus 4x to the 3rd plus 2x, all of which is over x to the 4th plus 1 squared.